A boy pushes a 40-kilogram crate with a force of 400 newtons parallel to the ground as shown below. A friction of 200 newtons acts on the crate. What is the crate's acceleration? The first thing that we're going to do in solving problems related to Newton's second law of motion is to identify the forces so that we could do the free body diagram. So in this situation, we have the force of gravity, Fg. We have the normal force, or the force exerted by the ground on the crate. We have the applied force, which is the force of the person on the crate. And we have the force of friction. So once again, in drawing the free body diagram, we just have to draw a dot in the middle of the object, and from this we are going to draw the arrows that would represent the forces, and the arrows should point in the direction of the forces. So we have the force of gravity directed downward, Fg. This force of gravity is counteracted upon by the normal force, and the normal force is going to be pointing in the upward direction. Once again, the normal force is equal to the force of gravity. So the downward force of gravity is cancelled by the upward force of the ground, or the normal force. The applied force in this case is directed to the left. So we are going to say FAPP, which is the applied force. And this applied force is counteracted upon by the force of friction. And since the force of friction is much lesser compared to the applied force, we're going to draw an arrow that is much shorter compared to the applied force to signify that the applied force is much greater than the force of friction. Since the applied force is directed to the left, then the force of friction should be drawn directed to the right. Once again, it has to be an arrow that is much shorter compared to the applied force. The question is asking for the crate's acceleration. Now, according to Newton's second law of motion, F net is equal to ma. And this F net could be on the x-axis, F net x, or it could also be on the y-axis, F net y. But then we already know that the forces on the y-axis, or the vertical axis, cancel out each other. That is the normal force and the force of gravity. So the F net y is just equal to 0, and therefore the acceleration on the y-axis is also going to be 0. So we don't need to worry about this axis. However, there is an acceleration on the x-axis, mainly because the forces here are unbalanced. So the net force that we're going to concern ourselves with would be the net force along the x-axis. And so we will start with F net on the x-axis is equal to ma. The forces on the x-axis include the applied force, and the force of friction. The applied force is directed to the left, so I'm going to say negative FAPP. Once again, negative, because the applied force is directed to the left, plus the force of friction, which is directed to the right, so that's why we have it positive, is equal to ma. Now let's substitute the values. The applied force, the magnitude of the applied force is 400 newtons, so we will have negative 400, plus the magnitude of friction, which is 200 newtons, is equal to m, which is mass, and that is the mass of the crate. So that's 40 kilograms multiplied by the acceleration, which is our unknown. So you could just plug these values in the calculator, having a as your unknown, and that would give us that the acceleration is equal to negative 5 meters per second square. And this makes sense because our net force is actually negative. It's directed to the left since our applied force is much greater compared to the force of friction, and therefore our acceleration should also be directed to the left. So the negative sign here only tells us that the object is accelerating towards the left. So the negative sign there is the direction.